Hello, everyone, and welcome to this month's Rancher Online Meetup. My name is Shannon Williams, and I'm excited to have so many of you with us today. Today, we're going to be talking about building an enterprise Caas using Kubernetes with Rancher 2.0. And as always, I am joined by my co-founder here at Rancher, Darren Shepard. Darren, good morning. Hopefully, it's a hot, sunny day in Arizona today.
Yes, it is.
Awesome. Well, you can find Darren and I on Twitter, and if you've got questions for us that we don't answer during today's meetup, please don't hesitate to hit us up there or on GitHub or anywhere else under generally these same handles. Just a couple quick housekeeping things for those of you who haven't attended one of our online meetups before. This is a meetup. It is not a webinar, and that's kind of a something we say every time when we start this, because there's a couple key things to know. The first is that we don't really put a hard stop on these events. They tend to run as long as everyone wants to stay and attend, and because of that, we record them. We share the recordings within a day or so. At the end of the meetup, I share the slides, and everything's out there to review. We're trying to get the questions and answers kind of consistently put out somewhere as well. So there'll be a lot of, I know people ask this as we go, but you should be able to access the recordings pretty easily. The other key things are, this is really meant to be an interactive discussion. A good meetup, there's lots of time for questions. There's lots of time to, kind of ask what you're interested in learning about. Feel free to do those. GoToWebinar has a good questions format, so fire your questions in. If you send a question in, I'll most likely reply to everyone so that other people can see your question and see the response. If for some reason you want it to be private, please write private on it so I don't send it off to everyone, and I'll try to reply privately to you, or Darren will try to reply, or we'll do our best to get back to you. But as a goal, we try not to leave until the questions are answered. A lot of the questions, if you ask them, I'll try to ask them of Darren, or Darren might ask them of me during the actual, while we're presenting. So we'll kind of take a second to talk through maybe something we glossed over quickly. All questions are welcome, really. There aren't any bad questions. We're talking about pretty advanced stuff often. We're demoing things that are often, a bit futuristic and sometimes on the bleeding edge of what Kubernetes, Docker, Rancher can do. So there aren't any bad questions. As a general rule, we really focus on demos in these. Everything is live. We don't pre-record or can anything. So when things break, please be patient with us. Because we've been doing this now for almost 2 years, we have thousands of people who regularly attend our meetups online. Please join us all on Twitter. We use the hashtag Rancher Meetup to talk amongst ourselves if we want to talk about this community. If you've got ideas for a Rancher Meetup, throw them out there. If you just want to introduce yourself, I'm happy to, please post your picture, put it up there, join in other people, and I'll put you up on our wall of friends to be part of it. The hashtag is Rancher Meetup. Just use that on Twitter. We also have a Slack channel that often people are engaged in. So thanks to all of you who come back over and over again to dive into this content. So today we're going to talk through really for us at least, a more enterprisey, businessy use case than we typically tackle with these meetups. And we're going to talk about what it means to actually build an enterprise Kubernetes platform and to put Kubernetes into into play as an enterprise-wide service. And there's a lot of interesting implications to this, right? I mean, Kubernetes, like most sort of technology movements, containers, like most technology movements, have been very much a grassroots, bottoms-up technology adoption, and we've seen that often when teams start to try to put them into a centralized service, the goals around controls and security and compliance start to make innovation a lot more difficult. So we're going to talk a little bit about what the future looks like as people start to build around Kubernetes. Demo will be Darren today. He'll be diving into Kubernetes as a service and talking about it. I'll just chat a little bit about what's coming up next, some upcoming releases and next month's meetup at the end. And as always, we'll be taking your Q&A. So the The big news since our last meetup is that Rancher 2.0 GA'd this month at KubeCon, and back at the beginning of the month, we released the general availability of Rancher 2.0. If you haven't already, definitely take a look at the website, and you can read all about the new release. You can find all the deployment information. As always, Rancher 2.0 is open source. It's available to anybody, and there's some great demos and some very good instructions on how to get started. We're still doing lots of work on the project. As you can imagine, it doesn't really stop with any one release. But right now we're working on 2.0.1, which we'll probably release today. And over the next couple of weeks, we'll be focused on the next couple of months, I should say, we'll be focused on 2.1, which is the next major release of the product, which will come out sometime probably towards the second half of the summer. So it was a huge accomplishment for the team. They worked incredibly hard. Darren and all the engineers, really spent a lot of time. I mean, 2.0 for us was a really complete reimagining of what Rancher was. In a world where we went from kind of running any orchestration and sort of seeing Swarm and Mesos and Cattle and other things as kind of key components of Rancher, to sort of realizing that Kubernetes was going to be not only a standard, but was really the best platform for running most production workloads, and then imagining what we needed to actually put that into production. So it's a release we're very proud of. We'll be talking about it a lot and demoing it today. But big congrats to the team and all of the community who helped make that happen. There were enormous amounts of contributions from people out there on testing and features and design and blogs, and people working on Terraform scripts and everything else. So thank you again to everyone who helped. So for today's discussion, I want to dive into this concept of what an enterprise Caas is, and what it may mean to build one on Kubernetes, and sort of what makes sense here. And typically when we do our meetups, we talk about kind of the value of building out your applications using containers. We might talk about networking or storage or CI, or we might talk kind of in depth about some new release or something else that we're developing on. Today we want to just sort of take a step back and maybe see the forest a bit more, see the garden a bit more instead of just the plants, and look at the direction of where Kubernetes adoption is going and how to start implementing and building around that. The reality is that Kubernetes, like Docker, it has grown from the ground up, and it typically starts with a single deployment. A specific team within the organization is often sees the potential to leverage microservices, or sees the potential to leverage Docker to improve the delivery of their function. I think probably 7 or 8 times out of 10, an organization is building a new application, or a team is building and modernizing an application and approaching it to use microservices, and that leads them down the path of containers. It leads them down eventually to Kubernetes. And for the most part, I think all of these Kubernetes deployments that I have worked on with teams that are sort of being driven by a specific use case or a specific application, those teams themselves have then built out and deployed Kubernetes. Often either they might build that in the cloud, they might build that on premise, they might sort of work with IT a bit to sort of build out the platform for it. But for the most part, it's owned by the DevOps teams responsible for that workload, that first workload that's going on it. And the project goes live, the team sort of basks in the success of having kind of rolled this out. They continue to iterate on it, but very often it creates Kubernetes Docker evangelists internally that go out and sort of pollinate the rest of the organization. And quickly what we see is Kubernetes usage expands and container usage expands. Other teams see the same benefits, see the same potential, and we start to see a broad set of use cases getting consumed. Again, some on premise, some in the cloud. I spent time in the last week with one of our larger Rancher customers, and they kind of shared just how broadly Kubernetes is being used. And just 4 of the examples they gave were so different, right? One was kind of your typical custom developed microservices application, which was where things started. But another group had centralized CI/CD and was building out a whole CI platform for all of the different development teams, sort of a developer services group. Another group was focused on machine learning and had built a hybrid TensorFlow deployment using GPUs on-prem and on VMware, and was also now expanding to consume AWS resources. Another group was using it for, kind of almost traditional hosting, where they were just running lots of different mobile and web applications and using it to deliver, kind of consistent platform for running those. And I think this organization had 27 different clusters running within, and it's very much the case that as we adopt containers as our medium for deploying software, we obviously need a production runtime operation system, and Kubernetes is that. And what's interesting is, very often those deployments are quite different. I spent time last week or 2 weeks ago at a media company on the East Coast, and they were telling me that, they've kind of now, that they've tracked and know of, they've got 65 different Kubernetes deployments, and for the most part, it's created a lot of innovation. They're starting to see some of the challenges where, as people leave, a lot of the institutional knowledge of how to run these, or what version they're running, or how they built it, or how to configure it, starts to become a challenge. And this is sort of something, I think, if you've been around technology a while, you'll have seen, right? It's it kind of happened with Microsoft back in the 90s. It certainly happened with VMware in the early 2000s, when teams started seeing the potential of using virtualization to get better utilization out of their labs. That was kind of the first thing. If you remember, it was all VMware was used for all these dev labs, and then before you knew it, there were hundreds of VMware deployments, and IT starts to come in and builds out vCenter automation, and begins to sort of try to offer VMs as a service. And interestingly, we see the same thing with Amazon, almost in some respect in response to that. Amazon kind of emerges as an easier way to get your hands on a VM. And, and all of a sudden, the number of Amazon accounts and the number of Azure accounts in an organization starts to spiral as well. And all of the response to that is IT orgs start to put in cloud management platforms, start to put in, policy and controls. And so, what do? We move to Docker, we move to Kubernetes, and we're going through the same thing. In fact, if you think about what it looks like, it really is sort of like this early adoption phase is all about the different use cases. But because these technologies are so transformative, and because they really deliver, they're useful, they achieve what says on the tin, they actually, the success drives more success, and pretty quickly the broad adoption emerges from the grounds up, and teams are very aggressively adopting it. Users are flocking to conferences. There's just a ton of interest and attention, and very often there's lots of different use cases and versions. In the cloud space, there might have been people with different types of cloud accounts. Some people using Rackspace, some people using Amazon, some people using Joyent, some people using Google. And then, over time, management starts to come in and start to see the responsibility at an IT level to kind of put some type of security around this. Where's my data? Who's using these things? What kind of controls can we have? And some organizations obviously stamp this out, right? Like they talk about shadow IT. This is a bad thing. We're gonna destroy this. But I think what we've seen is that the organizations who have let this happen have generally performed much better. And so when this standardization and management comes in, it really kind of, as you think about the implementation of controls and the implementation of security and compliance, the real questions become, are we actually expanding access? Are we improving utilization? Are we giving more people access to the system, or are we, putting so much in place that we start to neuter it, and the innovative opportunity disappears? And I think organizations have done a much better job with Amazon and cloud services than they did with VMware, where, if you remember, there was just a ton of response to sort of the proliferation of VMs, of putting in place a ton of controls, service desks, long forms to order VMs that, if you were in a lab, you could have gotten for yourself, in minutes, months before. Suddenly it took months to get a new VM. So as we think about this, the real question is, how do we avoid slowing down the innovation? How do we add the controls, or add the expand the access? How do we make Kubernetes a service without sort of killing off all of the innovation? I think to understand that, you have to kind of dive into what is really driving the adoption. Like what is at the core of why we're seeing this? And I think sometimes, when the hype on Kubernetes has gotten really high, we forget that the real game changer in this has been containers, right? Docker containers have enabled an enormous transformation of how we think of packaging and distributing our code. They've impacted, portability. They've made it dramatically easier to do testing, to see all of the components of a complex application in a single place. They've allowed for much more predictable deployments. They have simplified the process of doing upgrades, rolling upgrades and blue-green upgrades and all sorts of things. So we've, the value of containers, I think, is at the root of all of this. And if we find that the controls we're putting in place are somehow, kind of impacting that, we're putting so much around that it's difficult to even package our stuff because there's, so much security on what kind of containers can run and how they can run. We're going to, we're going to kill this flower before it can grow. The reality is that Kubernetes adds another set of value to this. In fact, almost, if we think of containers as being incredibly useful to a developer and to a person working on a single laptop to reinstantiate everything that they're trying to build, and valuable to the DevOps team, Kubernetes itself is really valuable to the operations teams, the people who have to run this stuff, the people who have to sort of imagine how these containers scale, how they deal with infrastructure failures, how they network with one another, how they deal with persistent storage, how they actually integrate to the other systems, the monitoring, the logging, etc. And so with the emergence of Kubernetes and sort of the cloud native ecosystem of tools around it, we're seeing a renaissance, I think, in tooling for DevOps teams from the sort of production runtime side. So if you think of all of this is all value achieved by a single team when they stand up Kubernetes and they adopt Docker. So when you think of sort of the organizational benefits of a container service or a Kubernetes service, the question is, are we just getting this value, or is there additional value that an organization can get? And is there cost or trade-off? Like, do we lose some of this value by putting in place the organizational benefits? Because if we move from these isolated deployments to a Caas, we have to understand what the value we're getting is. So I think at a highest level, the benefits of a Caas are I think they're things we can quantify. Certainly one of them is improved and more consistent operations across an organization. If we are adopting containers and we're all kind of adopting them in our own way, there's a lot of there's a big lack of shared knowledge going on how people are consuming it. And so, in this case, we want to imagine how how these operations will be consistent as different teams are running them. How do we standardize, things that are kind of mundane and we do often, like provisioning a cluster or, deploying infrastructure to a cluster. The other big benefit, I think, is one that it gets glossed over a lot with containers, but there's a big infrastructure density benefit that organizations are seeing when they move to Kubernetes, and that is the ability to build out clusters and share them between different teams and different use cases, and really improve the amount of utilization over what we're doing with virtual machines is kind of the benefit that I think a lot of IT organizations are excited about, that really doesn't impact, you don't see that as an important requirement for the teams actually running their application. So if we can achieve some of that density and give people access to shared clusters, give them access to resources that maybe are less expensive, or where they're sharing the cost across more people, then it should allow for, again, more access to scarce resources like GPUs, and a decrease in the cost of infrastructure for an organization. There is definitely needs to be a focus on security and compliance and standards around how teams are adopting this. Like any production systems running production workloads in large organizations, the ability to kind of document and understand what's going on, who deploys things, what changes are made, and how they were made isn't going to go away, right? I mean, organizations have control and compliance requirements. They need to be able to show that that they put in place controls on who can access and touch and manage systems. So this is the big, kind of requirement that I think, consistently is difficult to deal with in any of these technology changes, if everyone does things their own way. And so, it is a fair requirement for the IT team, but it tends to be the one that causes all the problems too. So if we think about this as the big benefit is, okay, IT now has visibility, they can see everything, they can ensure that, only authorized people have access to the right systems, and they can show that to the auditors. Is there a way to do that without necessarily, forcing everyone to drink the exact same kind of milk? And then, I think the other big benefits are around actually new business cases being solved. We, as organizations, we're trying to, achieve, we're trying to leverage cloud computing to expand our capabilities and solve business problems and do more innovative things. Being able to support multiple cloud providers today is still very difficult. Kubernetes, in so many ways, represents this potential serial port, HDMI port that gives us access to lots of different places, but allows us to run the same application in those places. And so the benefit there to an organization of being able to say, look, you can use whatever infrastructure you want, as long as you're using it in sort of an approved way, is going to open up a lot of functions and capabilities that exist sometimes only in one cloud provider. And exposing those out is one of the big benefits that I know a lot of IT organizations are kind of struggling with. So as we think about all of this kind of unlocked benefit, the requirements then kind of need to be well understood. So what exactly are we talking about when we talk about a Caas? And for me, what we're going to demo today, what we're going to go through in our demo today is what an enterprise Caas would look like. And the key requirement is basically that it has to bring together the users and their requirements and their need for exactly the capabilities they have with the the wide array of infrastructure options that exist in a modern enterprise with sort of the IT organization and its policy requirements. And so what we see is kind of the difference in projects and organizations that are trying to move in this direction is that instead of starting with a specific project and a specific application's requirements, they tend to start with how this container service is going to connect and work with the existing IT systems, right? Their existing directory services, the container specific, things like a registry or maybe a security tool, certainly their existing or new monitoring platforms, the service desk. And so, the container service, how it's typically differentiated from just building a cluster is that it's integrated once into these different types of systems, or it connects to them. And then, from there, the teams really should have self-service access, right? So a new team that needs access to Kubernetes should be able to come in very quickly and say, look, I need to run this workload in Google. We want access to some of the machine learning tools that they have access, they've made available. So I need a cluster in Google where I can start deploying my workloads. And that cluster should be able to be accessed through my existing AD credentials. I should be able to hopefully have the company pay for it, not have to put it on my credit card. And I should be able to be confident that I'm not going to get a lot of pushback from IT that we're doing this, that it's already been approved or it's already been sort of validated. So that's kind of the desire, and the same goes for team 2, who has a different set of requirements and maybe wants to run in Amazon, or team 3 has a different set of requirements and wants to run in a data center on VMware, or even times where multiple teams want to run on the same cluster, but they don't need the same level of isolation of needing the clusters, but they need to still know that they have control over their workloads and their namespaces and their system. So this is what we're really looking for, is what can we show about how these pieces come together, how users can be isolated, how we can develop this. And what we want to kind of lay out is a set of requirements that we think are critical to making this happen without kind of moving to the totalitarian state scenario that I think we experienced with VMware, and we experienced with some kind of some of these transformations where the controls really nip in the bud the potential to innovate. I mean, common complaint, I want I need a specific version of Kubernetes, or I need to run it in a specific place, or my Kubernetes needs to have this type of infrastructure supporting it. I can get all those things myself. I really don't want to have to kind of eat your common standard oatmeal. So what we want to cover today is kind of this idea of how do we deploy or manage any Kubernetes cluster, whether, it's sort of homogeneous and it's the kind of standard deployment model of the organization, or it's more of a snowflake that a team has developed themselves for, often very good reasons. We need to kind of be able to accept both of those types of things. We need to be able to imagine, kind of the user experience. We have to be able to understand, isolation between those users. We need to kind of put in place, hopefully, a security model that's quite flexible. We want to, leave this thing with something that actually encourages adoption. What can we do to, make adoption easier? What can we do to, sort of find, at the very least, sort of pathways that maybe, common approaches that many teams can use. So those are kind of what we're heading to try and demo in today's session, and we'd like to sort of steer the conversation into these key requirements. And on each of them, we're gonna kind of drive into them, talk a little bit about them. So hopefully they'll give us a framework for the demo and the discussion. But we want to look at how within a Rancher deployment, we can kind of both deploy our existing clusters, deploy new clusters, but manage existing clusters. We want to kind of talk about the difference between, these new cloud-hosted versions of Kubernetes like GKE and EKS from sort of on-premise implementations of Kubernetes, and how, both of those, should be exposed to users. We want to talk about, kind of the concept of operating these clusters. How do you back it up, upgrade, restore clusters? How do you sort of define and entire cluster deployment as code? These are sort of key requirements, I think, for an IT service focused on Kubernetes. Is it's got to understand that you're probably not going to, the answer is not to create a homogeneous, here's Kubernetes, we will give it to you everywhere. It's going to have to be, there are different reasons to run it in different places, and often they mean using a slightly different version of Kubernetes with different configurations and cloud provider functions turned on. And in many cases, it's going to be much more efficient to use the cloud-hosted versions of Kubernetes than it is to implement it yourself. So we'll go through that a little bit. We'll talk about, some different workload isolation models. When users are coming saying, look, I need a Kubernetes cluster, it's very reasonable to ask, do you really need a cluster? Or do you just need a namespace? Do you need access to some resources on a shared cluster? So we'll talk about different types of clusters, dedicated, shared. What does workload isolation mean in a shared? And more importantly, what is the user experience like, right? Like often, the reason someone's asking for a dedicated cluster is they want to be able to change the config, or they want to be able to have, a lot of control over kind of how other people can access it, or they want to be able to share resources, or they need to have, dedicated, kind of chunks of resource that they know no one else can access. So we'll talk a little bit about workload isolation. We'll then kind of look at the user management problem and try to imagine, how do we sort of integrate the system with different user systems? How do we kind of identify the concept of cluster managers and project managers and users, and hopefully allow teams themselves to define and create their own security policies? Because often that's the real, you think about where the rubber meets the road. Often the DevOps teams are just as focused on security. They just often can't fit the requirements they have into maybe 2 or 3 buckets of here's what a user can do, because they need to be more nuanced. Someone can do this, but they can't do that, but they can do this. So we really wanted to kind of imagine how roles could be created, but also forked and modified, just like we do with other things, and still be able to be traceable and auditable by an auditor to say, yeah, this was the right decision, and here's why it was the right decision. Or actually, this isn't secure. Your model's a very bad choice. You've granted everyone way too much access, and can we have a discussion about that? So we're going to talk about access and users and identity management. We're going to talk more in depth about security and policy management. What's the role of pod security policies? What is, does it make sense to have standard things turned on and off everywhere, or are we really kind of going to be looking for an adjustable stance that can change, based on the individual use cases of users? And then finally, I really don't want to leave without talking about sort of the real elephant in the room, which is that very often IT organizations build, invest in big platform projects, and what they end up with is something that doesn't get consumed because, these projects don't keep up with innovation. The industry moves way faster than typically big platforms do, and on top of that, there often is so many controls that that organizations find that development teams and DevOps teams find it more efficient to somehow break out of the controls, break out of the systems, and go do exactly what they want to do. So can we imagine a platform that gives users all sorts of different access options, from the CLI to the UI to the API to kind of extending some of the value? One of the things that users do like from IT is when things are well integrated, right? If I can just turn this on and it automatically signs me into everything else I'm using, and I can quickly move back and forth between my monitoring and my operations panel, and I can see my logging, and I can quickly drill down into things. So where are there opportunities to streamline and drive adoption? What do we need to do to innovate around the user experience? And how do we do all that without locking people into a bunch of tools that are inevitably going to go out of date and are inevitably not going to be the ones that they want to use 2 years from now? So really focusing on flexibility, application catalogs, and kind of exposing the richness that's within the Kubernetes ecosystem, right? I mean, I don't want some little curated catalog with 3 or 4 things that is approved by IT. I'd like to have access to everything in Helm. Is that okay? Is that acceptable? What are the options out there? So we'll talk a little bit about those things. So with that, I'll stop. I think there was more slides than we've probably ever gone through. So this is the danger of having an enterprise type conversation, but hopefully it gives you some context around the challenge that is coming as we move from the Wild West to the emergence of cities. And I'm going to turn it over now to Darren and have Darren dive into his demo. Darren, you should now be the presenter. Can you share your screen?
Yeah, I should be sharing my screen now. Okay.
Awesome. You are live.
All right. So I'm just gonna go through and demo quite a bit of the how to actually accomplish some of the concepts and whatnot that Shannon's been talking about. So typically with these demos, I pretty much always start from scratch because I just always like to show that just how simple it is to get this stuff up and running. So that's kind of where we'll start here. So I'll go through and I'll deploy Rancher, and then we'll set up some clusters. In the past couple of meetups, like the last 2 meetups, we've gone through pretty heavily, shown how provisioning works and demoed that quite a bit. So I'm going to rush through a lot of that, but there is a lot of content already on previous meetups, and if you have any questions, just ask them. That's fine. So I just want to show. So what I'm doing is I'm going to run the single node setup. Now, we have 2 different approaches to running Rancher. There's like the single node, which is a Docker container, or there's a full HA setup. Really, I kind of wanted to make a point, like letting people know, it's like, unless you really, really, really need HA, it's so much simpler to run like the single server setup. It is still a sane production setup. It's just not going to give you high availability. So you just have to consider, if the application goes, like if Rancher was to go down, could I, stand a little bit of downtime? Because what Rancher is just a management platform. Kubernetes continues to run fine. It's just whether or not the management UI and CLI API is available. So it's significantly easier, because we just see this a lot with a lot of our open source users who are running smaller deployments that really they're much better off just running a single node setup. It's a lot easier, it's a lot cheaper. The only thing you really have to consider is you need to back up the state, which we put into this directory var lib rancher. Just put it somewhere on the disk. So if you're just running like a VM with EBS, put it on a persistent disk and you're pretty good to go. Otherwise, you can go through the whole HA setup. HA setup does require 3 servers with about 8 or 16 gigabytes of VM or RAM. You have to have proper DLS certificates and whatnot, and it gets a little bit more complicated. There's more variability and chances kind of to fail there. Oh, oops, I think I already had one running. Let me delete this. 579. Anyway, so let me start up this container. So that should be running. Just takes a couple seconds for Rancher to come up. We kind of watch it here if you want, so you can see it's already listening, so it should be up and running. With a single container, we have Let's Encrypt built in to it, so it's super nice. You just, everything comes up, you get a perfectly valid cert. This is very secure. So it's really a nice nice approach. Okay, let's see. I think it's still loading. Reconciling. Just give it a second. Why is it not coming up? Okay. Let me see. Okay, let me just delete the container and start again. So this is just a fresh setup, doesn't really matter much. The joys of, I just want to make sure I'm going to remove this because I might have just pointed to a backup of a different one that I was running. So I'm just going to start with a fresh state. Sorry about that. Okay. We'll be up in just a second. Yeah, I'm sorry. When I launched that one, I think I pointed to the directory where I was running a different one. So I used like the state directory from a different installation. So this looks better. It's coming. This should be coming up properly. Okay, sorry about that. I don't know why it took so long. So when you first come up, it's going to ask you to set a password. So we're going to go through all the authentication and authorization stuff. And so when you're setting a password, please pick a secure one. Don't just put in like admin. So here I already have a secure password in my password manager here. Invalid current password. Okay. Okay, so when we come in, so the very first thing you're going to do if you're setting this for like kind of a production setup is you're going to want to turn on authentication. So here in this demo, I'm going to use GitHub. We also have Active Directory. Active Directory is a little bit more involved, the setup. You need a proper Active Directory and whatnot. GitHub is pretty straightforward. We have the Azure version of AD coming, and then I think SAML and some other authentication that are coming very shortly. But we're just going to do GitHub. That's the simplest one to get up and running. And so if you just follow these instructions, it's pretty straightforward. You basically just need this URL. So it's going to tell you, okay, click here. Create a new OAuth application. I can call it anything you want here. And you just need to paste in these two. This URL in these two places here. Okay, and then once you have that, you just need to copy back over the client secret. And sorry, that was the client ID, and then the client secret. And when you click here, it's going to go through, it's going to do the OAuth authorization. It's going to test that everything kind of works right. If everything's good, the screen should refresh, and then we should have GitHub turned on. So let's see, it's refreshing. Okay, so now I have GitHub authentication turned on. So there's one thing I want to point out. When I first brought up Rancher, it asked me for an admin password. That admin account and password is still valid. Like it's still set up as a local user. So again, that's what I was saying. When you first bring up the site, make sure you put a secure password in there, because that account is still there. So like we have both. We have basically essentially like a local account enabled and GitHub. Because if you were to kind of mess up GitHub or whatever, you can still get in through that first admin account that you set up. When you're setting up, so now that we have GitHub turned on, we have to determine, well, how do we want people to have access to this setup? Because there's different approaches here. First, you can just say any valid user. So basically what this means is like anyone with GitHub could just log in, which, I mean, for GitHub, that doesn't really make sense because that's public. But if you have GitHub Enterprise, then basically, hey, if you have a GitHub Enterprise account, and we do support GitHub Enterprise, there was an option there that I kind of brushed over, but there's an option to select GitHub Enterprise. You can just put in the enterprise URL. But so one of the approaches is you just say, okay, well, if I have like GitHub Enterprise or I'm using AD, anybody who has an account, they can log in. That's fine. And then that will just make them a user. It's going to make them a user, and I'll talk about later what exactly a user can do. Then there's other options here, is saying the only people who can log in is anybody who has been invited. So if you add any member to a cluster or to a project, or in this group to the left here of authorized users. So here, this is kind of an invitation only model. You can only get access if you've been basically invited to the site. And then the last option here is very strict. It's just saying the only people who can log in is these groups and users. It doesn't so if somebody goes in and within your, this is the most strict one. So like a user can come in if they say, okay, I want to invite, this other user as a member of my project or my cluster. They're not going to have access to the site unless they're in this list. So this one gives you the biggest degree of control. So I'm actually just going to put it on allow anyone right now, just for the kind of the purpose of demo, and I'll show how that works. So let me just save that. Okay, so right now, since I'm the one who turned on authentication, I am the admin. I can go in here. This is the account I'm using right now. You can say this is my local admin. This is the local account, because as I said before, when you first set it up, that admin account with the username and password is still there, and it's associated to this first account here, but this is also associated to my GitHub account. But I can go in here and I can see the permissions for myself, which basically I'm an administrator. I can do absolutely everything. So as you add in more users, so if you're adding in users, you can specify what level of permissions they can have. This is at the global level. So for authentication, for authorization, there's kind of 3 levels you have to look at. What can they do globally, which is really an administrator of Rancher itself, the deployment of the management plane. Then there's the cluster level, is what can you do within a cluster, and then the next level is the project level, which is what can you do within a project. And just really quickly, because I mentioned project a bunch of times, project is a concept that's kind of unique to us, and all a project really is a group of namespaces. And when I get into showing kind of the authorization stuff around projects, hopefully it'll become a little more obvious why we created it. All of this basically comes down to why we created projects is we wanted to give people the most amount of control to be able to deploy and run Kubernetes the way they wanted to, but we really don't want to destroy the self-service aspect. If you want self-service, we're going to enable you to continue to allow self-service with Kubernetes. And projects basically gives us a way to do that. It gives you a way to basically set up a policy so that users can still create namespaces, but since it's in a project, it gets assigned the project policy. So here, when you add in a user, so basically there's 2 approaches at the global level. If you're just adding a user, you can say they're an administrator or a standard user. really, like within an organization, you wouldn't really have a lot of administrators. Like these are the people who have absolute control over everything. They can see everything in Rancher, all the clusters, everything. So that's not something you're really going to want to hand out to most people. That's like, basically like root for the whole system. A standard user, basically what a standard user is they can just come in and they can create clusters. So once you create clusters, then you have to deal with, they becomes the cluster owner, they can manage the privileges of the clusters, then you create projects and it like starts delegating down. Or if you don't like kind of our definition of what a standard user or administrator is, you can create custom. Because right now, like a standard user, basically what they're allowed to do is they're allowed to create clusters and I think use catalog templates. But some people might say, hey, I don't want every user to be able to create clusters. Like that doesn't make sense to my organization. So, you can add users in and say, okay, don't give them that permission. Okay. All of these things. So what I've been showing here, like when I say, okay, when I went to add a user, like these different, what these custom roles are here. These roles are defined globally, and you can create all the roles, all the different type of roles you want. This starts getting pretty advanced if you have to create custom roles, but you can do it. You can start doing some pretty advanced things. But we've gone through pretty painstakingly and figured out a lot of the roles that would make sense. But for someone like, because you're saying something like, I'll just give you an example, like somebody who's like a cluster member. What that actually means, it gets down to the individual API level. Like these are the resources they're allowed to see. They can watch them, they can list or get, or they're allowed to create. Like it gets down to a pretty painstaking detail. You can inherit from other roles, so you can kind of aggregate them together. So, I mean, if you need to, this can get really, really advanced. You can do a lot of interesting things. What we have out of the box for the roles seems to cover a lot of the use cases. And we're continuing to tweak this as we get more user feedback and whatnot. Okay, so let me go through. So all I have right now, I've turned on authentication. I just have one user in the system. I'm going to deploy some clusters just so I can kind of show the access control. So I'm just going to quickly, what I'm going to do is kind of show. So here's an example of basically creating a GKE cluster. So this is a cloud managed one. This is one where Google basically manages the cluster for you. At this point, you can add members. Right now, I'm just going to do everything with no additional membership. We'll do that all after the fact. So I can just spin up these clusters real quick. So here I'm going to do this one. This is going to create a cluster using GKE. Let me add in another cluster. This one I'll do on DigitalOcean. This is not using DigitalOcean service. They just announced one. It's not actually public yet. We will have support for that as soon as it's public. But what DigitalOcean is it's actually using our managed distribution of Kubernetes. So it's what we're going to do is we manually, like through Rancher, we spin up their VMs and we deploy our distribution of Kubernetes. So this is like a Rancher managed Kubernetes as opposed to like GKE is a cloud managed Kubernetes. So here, we launched demo 3. This one's going to be DO. And in order to do this, since we are actually spinning up the VMs, we have to create node templates, which define what the nodes, like how much RAM they have and everything like that. Again, I'm going to kind of run through the provisioning really quickly because we've covered this quite a bit in previous meetups. Let's do something a little bigger. Okay, you can spin up as many VMs as you want and using as many node templates as you want. I'm just going to keep it simple. I'm just going to do one VM. Okay, so we have the GKE one running. We have the DigitalOcean one That one's deploying too. And then the third kind of style of cluster I'm going to show you is it's just basically doing an imported cluster. This is like, I created a cluster through other whatever means. You have your own way of deploying Kubernetes, but you still want to manage all the authentication, authorization, and give access and all that stuff that Rancher provides. So we're just going to import. So when you do an import, again, I could specify member roles. I'm not going to do that right now. When you do an import, basically, it's just going to tell you to run this kubectl command. So I already have on my command line here, like what was it? It's cluster info. Yeah, so I already have some Kubernetes cluster running. So I'm just going to run this, and that creates some stuff that we should see importing once. So when we run this, it deploys our agent, which will do the registration process. System. So right now, let's see, desired current, it should be up. Oh yeah, it's up, okay. So that one imported. So this one, there's no provisioning of Kubernetes, so it comes up super fast. So now what I have is basically I've got 3 clusters. So it looks like the GKE one is already provisioned. The imported one, there was no provisioning, we just imported, so it just came in. And then we have the DigitalOcean one, which it's going through and right now deploying Kubernetes. Okay, so now I've got some clusters, I have authentication turned on. So now I'm just gonna kind of show you how you can go through and set up like the delegation and how to give people access to clusters and projects and whatnot, and how that works. So what I have here is on this screen, I'm logged in as one user. This is my GitHub account. And then on this screen, I'm getting feedback. Does anyone else hear that? Okay, let me see. Okay, sorry. So on this screen here, the black background, this is like a privacy session or whatever in Chrome. So this is going to be a different GitHub account. So I'll be able to show you the kind of adding a user, authorizing, and everything I'm going to show, like I'm going to do it with a user, like adding a user, but it works with groups too. So like anything, like you authorize a user, you can authorize groups too. So typically when you do this, you're really going to want to do groups. It's obviously much easier than specific users, but just depends. Okay, so let me go. Okay, so this is my demo one. This is my site that I set up. So I'm just going to log in here. So when you first log in, it says this is GitHub. It's going to ask you to authorize. So it's going to come in. So when I set up the security before, so before when I was showing you, I set up GitHub. I said allow any valid user. So what that's going to do is anybody with a GitHub account can come in, and it's just going to set me up as a standard user. And before, what I was showing is what a standard user is basically they're allowed to create clusters. So I come in here, you can see if I go to the clusters tab, there's no clusters. Even though I've gone through here, like I've deployed 3 clusters, I don't see any of those because I'm not a member of those clusters. But I could go and deploy my own cluster. So at this point, once I create the cluster, I become a cluster owner and I can start doing whatever the things that I want. But since I'm just a standard user, I'm not allowed to kind of mess with the global setup of Rancher. And we're continuing to tweak the UI and refine it. Right now, a lot of the operations you can't do, we're not currently hiding. So I'll show you, like, let's say like node drivers. So as a regular user, I can list and I can see, well, here's all the node drivers that are available. But I couldn't, for example, go in here and delete it. It's gonna blow up. So we're gonna continue to tweak the UI and just make it so you don't even show the things you can't do. But just because there's a button right now doesn't mean you can actually do it. If I click on it, it's gonna prevent you. because it is properly enforcing everything. So since I'm a standard user, I can't do the kind of the global administration stuff, which is when I look at this menu here, global, basically I can't modify anything at this level. I can't turn on and off catalogs or add more catalogs. I can't change any of the settings. I can't change, I don't even think, so I can't add any policies or change any of this stuff. And then users, you can list the users, but you're not going to be able to see. So you can see like what users are available, but you can't, I'm not going to be able to see any of the permissions of the users. Not even myself, to be honest, because I don't have, not at the global level. It's not going to tell me. I have no global roles, basically. If I had cluster roles, it would show it, or project roles, but I haven't created a cluster yet. So I'm just going to show you. So if I just go in here, let's say we create a custom cluster, custom demo. Okay, that's fine. Okay. So I've gone here and I've created this custom, like what a custom cluster is you just run this one Docker run command, and then it will, if like you want to provision virtual machines however you want, you just basically run this one command, and then it will register it into the cluster. So what I'm doing, like right now, I'm not actually creating a real cluster. I guess I can just, make this a little more realistic. I'll create an actual cluster here, just so you can see. The user I'm using right now in this black screen is Rancher Dev. So here, let me go and I spin up a cluster. So here, this is going to spinning up another GKE one. So here are the two clusters that I own. Like I've come in, I own those ones. If I go back here to this other account, which is like the global admin, I can see those. So it's like I can see them because I can see, like this account can see absolutely everything, can do everything. But this user can only see whatever he wants. Now, if I wanted to go and invite a user, so now I can go in, okay, let's say to this GKE one. I can go to the cluster and say, well, who are the members of the cluster? And I can add members. And so the user I'm using is Rancher Dev. So now at this point, Rancher Dev. At this point, you can say, what type of, do you want it to be an owner, a member, or custom? So again, custom, it's going to give you like the fine grain. But the kind of the owner and member is typically what you want. Owner means they can do anything within the cluster. So they can manage storage, networking, create projects. They can do absolutely anything. A member basically can just create projects, which is like the equivalent of creating namespaces. So they can't, so as a regular member, they're not going to be able to do anything like storage or manage nodes, anything that in Kubernetes is not a namespaced object. It's a global object. A member is not going to be able to do. But then again, you could do something custom and give them specific privileges. So here I'm going to say, okay, Rancher Dev is now a member of this cluster. So this demo 3 GKE. So now if I go here, let me just refresh. I can see now that it shows up. I can see this demo 3. But if I go in here, members right now, we let them see nodes, but they can't modify them. But let's say for like storage is more of a global concept, or that's like a global cluster concept if you're just creating PVs. So if I go in as, this is the admin user, if I go in here, storage, and so if I add a volume, my volume, let's see, GK persistent disk. It works. Okay, so I've just associated a Google persistent disk to this here. Now, if I go over into Okay. Like I shouldn't be able to, like I can see them. I shouldn't be able to like delete the volumes. Okay, so basically what you can do from like a storage perspective, because Google has like, I'm sorry, Kubernetes has a bunch of different approaches on how to do storage. There's dynamic provisioning and then there's static provisioning. The dynamic provisioning is through a concept called storage classes. What I just showed here of adding a volume, this is like static provisioning. So basically what you're doing here is somebody can come in and go and define volumes, and then the users are allowed to use the volumes. But they can't modify, like they can just use it. They're not the ones who are creating or deleting them. So in this situation, like you could set up a user who's like just basically allowed to manage storage if you want to do the static approach. And then users can just consume them. And you can even go as far as like basically not even letting them list them, so they would have to only know them by ID. But again, that's getting pretty advanced. Okay, so now right now I've been showing the cluster. So I added this user as a member of the cluster. So I can go back to membership here and say, okay, this is me. I'm the cluster owner. I added this Rancher Dev as a cluster member. So now you can see there's a project already in here called default, and the default namespace, these are the namespaces, is assigned to that project. If I go over to this user, he sees no projects. So I added him as a member of the cluster, but that doesn't mean he automatically gets access to projects. So basically, like the key thing of what a cluster member can do is they are allowed to create projects. So I can go in here as a regular user and just basically create a project. So this project, I can then add namespaces to it. And once I have this project, I can then manage the access control for it. So here I am, I've been added to a cluster. I'm allowed to create projects. I can now, since I created a project, I'm the owner of the project, which now means I can start inviting other users or doing project level things. So let me get down into, I'll show you now, once we're in the project level. Sorry. So the projects, this is where the namespaces are. This is where you actually deploy containers. So here I can just go launch. That's gonna launch a container. This is just running Ubuntu, just for a test. So here now I can add members to this project. So since I'm an owner, I can add members. So again, it's kind of the same thing. There's owner, member, and then read only. Those are kind of the default ones we have built in, and then there's custom. And there's quite a bit once you get down to the project level what you can do, like if you can create namespaces or all the various different types. Manage basically means you're allowed to create and delete. View, you can just list. So now that I have my project, I can go and I can invite users. They can collaborate on the project. So like one thing I didn't show here is, let me go and remove what I'm going to do is I'm going to remove this user, just kind of to reset all the privileges, so I can just kind of show you this. So if I go in here, I'm just going to delete that user. It's going to revoke all of his privileges. You can't do anything now. So if I go back in here, I should get probably logged out, log back in. Okay, now I can see nothing. Like I lost privilege to all this stuff. Even the clusters I created, I lost privileges to them since we deleted the user. But the reason why I want to do this is I want to show, so besides just adding someone to a cluster, what you can do is you can go directly into a project and just add someone as a member of a project. And so now this user rancher dev is just going to be a member of this one project. So now coming back here, if I refresh, you'll see now that allows me to see the cluster. But for example, like if I go to nodes or storage, I'm not going to see anything because I have no access to the cluster level. I've just been added as a project, so I can't see anything cluster level. I'm only going to be able to just go in and do kind of the workload stuff, just whatever's within the project, the workload stuff. Okay, so that was kind of like a whirlwind tour of a lot of the authorization stuff, basically how you can set up different roles at like a global level, a cluster level, a project level, inviting users. I mean, there's a lot you can do. The key thing, I mean, to be honest, it was really quite difficult to put this all together to manage this all properly. Everything we're doing is, the way this works is we manage kind of the policy, like the roles, everything that you've defined, and then we push it down into Kubernetes RBAC rules. So everything's being enforced by Kubernetes, their standard Kubernetes RBAC rules. We just basically kind of have our policy of what it should look like and then make it so. Honestly, we put a lot of effort into this, trying to figure out ways to make this so it's really self-service, because the big thing that we've seen is as people are deploying Kubernetes and they're trying to lock it down for like enterprise, so users can't do things they're not supposed to, they basically end up restricting them too far. They have to go to another team to create a namespace. It really just slows things down dramatically. And so we're basically trying to find that balance of being able to have control but still allow self-service. And then for people who really want a lockdown environment, it is still possible. You can still just really lock it down and not allow users to do anything. But we really don't think that's the best approach. So the next topic I'm going to go through is pod security policy, and I think that will probably be the last topic I talk about. I don't know if there's any questions we want to handle right now before I can.
Yeah, there's a whole bunch of questions. One of the questions that I think came up a couple times was sort of, questions about, how you manage etcd on the back end. How is it backed up? How does it get recovered when you have these different clusters? So some of the operations of the clusters, that'd be a nice thing to touch on. And then, I think there were some questions about the how to run on different types of infrastructure, VMware, EC2. There were a couple of different questions on that, but I think things we can look at. There was other questions about networking policies, like are networking policies automatically configured? Is the network encrypted? So maybe you can talk a little bit about networking and operations, and while you get ready for the next piece. Also, I know we're now over an hour, guys. Just to be clear, we record their demos. Everything is will go up on YouTube so you can see this stuff, but I'm sure we'll go for at least another 30 minutes. There's a lot of questions to answer here.
Yeah, so the first one was kind of like backing up and managing etcd. So I mean, there's a lot of flexibility. Like when I go in here and I say, okay, how do you want to add a cluster? So we have, these first three boxes, these are cloud managed. These next three ones are rancher managed distribution, or vSphere is also. And then we have custom and then import. I mean, there's really a lot of different ways to for rancher to consume a Kubernetes, like for us to use and manage a Kubernetes cluster, whether or not we're managing it, you're managing it, whatever. So if you're running with a cloud managed one, then it's up to however the cloud does it, for like backing up and restoring etcd. I'd say GKE is really the most advanced in cloud Kubernetes distribution right now. They give you some control over kind of how you roll out upgrades and whatnot, but there's not really, I don't think there's anything you can do specifically about like backing up etcd and restoring it, because they manage that all themselves. It's just a black box, because for these cloud managed distros, often the control plane is not visible to you. Like you just see worker nodes. So they just do everything for you. So there's pros and cons of that. And that's why, like you'll see here, we have like Amazon EKS, which is the cloud managed service, but we also have Amazon Azure here, which is like Rancher managed on Azure, or this one is a managed by not EKS, sorry, Azure Container Service. Sorry about that. So Azure Container Service, or these, like both of these are going to give you a Kubernetes cluster on the cloud, but this one's going to be managed completely by Microsoft Azure Cloud. This one is going to be managed by us. We have users that go both ways on, like some people want it, it's typically cheaper to run this approach, but you have less visibility and control. This one, we have more visibility and control. So for distributions that we're managing, like that are actually using Rancher's version of Kubernetes, we give you the ability to back up and restore the etcd database. Basically, right now, that backup is just pretty much being backed up to another directory on the host, which means, and it's doing it across all the masters. So we're constantly backing up to another directory. So you can put shared storage or some type of persistent storage there, like NFS or EBS, and that will allow you to back up. And then in the case where you need to do a restore, typically, basically what that means is bringing down the control plane, and then going through the restore procedure of etcd, which is a pretty manual procedure, to be honest. And then bringing the etcd back up, and then bringing the control plane back up. And then the worker nodes will then just essentially all sync up to whatever. Because if you're backing up, there's a whatever the interval you put for the backup, there's a certain amount of window that you could lose some data. But that's kind of the reason why you run etcd to begin with, is etcd is supposed to be highly available. So the backup is really like, that's your disaster recovery. That's like really worst case scenario, that typically when you have a full site outage, which does happen. We see that because etcd can't run across like regions that have a like not a good connection. So we do see that, like, somebody will have a full site outage, brings down etcd, and then they'll have to restore from a backup. So again, like the management of the etcd, like backup restore, is really, it's up to however the cloud people do it, or if it's a distribution, a Rancher distribution, we kind of automatically do that for you. Right now, it's a second, like once you deploy Kubernetes, you do have to turn it on. We have documentation to turn on the backup. I believe we're just going to make that automatic, so you don't have to specifically turn it on. But it is a second step right now, and it's documented. Other questions was there's something around network policies. So basically, right now, so whether or not you have support for network policies and whether or not they work is largely determined on the cluster itself. So GKE, I believe, has network policy support. Some of the other ones don't. It just all depends on how you deployed and which plugin you're using and whatnot. If you're going through Rancher, if it's a Rancher managed distribution, we have network policy turned on by default. We're using Calico's policy manager. And so that's turned on. And then what we do just automatically out of the box is any namespace within a project can talk to each other, but namespaces in different projects cannot communicate with each other. So the in-cluster communication is locked down to just the project. And so we just do that by default. You can still go in and create your own network policy rules at a namespace level if you want to grant more access, do more advanced things. But right now, we just set up that one default rule. We will have down the line like more ability to configure the network policy. But right now, we're just setting up a default one just to make sure that, like, if you have two different projects, they can't talk to each other. So you're going to get isolation there out of the box. Can't remember. Shannon, I don't know if there's anything else.
No, I think just why don't you dive into the part you were going to cover next?
Okay, so the next thing I want to talk about, so everything we're talking about right so far has been around access control, who can see what. Now, the other thing you really need to consider is, the workloads people are deploying, what access to this workload have. So I just mentioned we automatically lock down the networking, so you can only communicate with namespaces in your project. You can't go across projects. You do have full outbound access. You can go out to the internet, or if you create host ports or services like a cluster IP service, we automatically set up network policy rules for you. So that's one thing that we do with network policy is network policy is very strict and explicit. So if you say like, oh, I want to expose, this service or this node port, it's not actually going to work unless you set up a network policy that also says allow in traffic. So because of that, it makes it kind of difficult for a lot of people to leverage network policy. So what we do is for Rancher managed distros or Rancher managed Kubernetes, or sorry, any Kubernetes. It doesn't have to be ours, like our Kubernetes distribution. It's just any Kubernetes that you're using with Rancher. We automatically will set up network policies to, if you've set up host ports or services, node ports, cluster IP, those type of things, you basically have already said like you want to allow the access in because you set that up, like ingress or whatever. So we set up the network policy and automatically grant in the access. So that's one thing to consider is the networking. The next is what is the users allowed to do in terms of like, can they run privileged containers, or what can the containers do? Because in a default setup of Kubernetes, really a container can do anything. Effectively, a container running in a Kubernetes cluster pretty much has root on the host. That's the default setup of a Kubernetes setup, and that's actually how most people run. So in order to lock that down, there's another concept called pod security policy, and pod security policy honestly is not leveraged very much with what we're seeing with people doing production deployments. And honestly, I believe it's because it's very difficult to use. In Rancher, I think we've done a pretty good job of making it really easy to use. So I want to go through and show how you set up pod security policies and apply them. Now, again, pod security policy is whether or not it's even supported by your cluster, it depends on the Kubernetes cluster. So most of the cloud-hosted ones, like a lot of the cloud-hosted ones don't support it. I think GKE does, but you have to turn it on as an option. Ours, like our Kubernetes distribution, we support it out of the box. So this one, if you want to do pod security policy, you really have to look at what type of Kubernetes distribution you're running and if it's even supported. So here I'm going to go. So this DigitalOcean one, this is running a Rancher distribution of Kubernetes. Oh, hold on. Before I do that, before I actually turn on pod security. So you have to define pod security policies. So out of the box, we don't have any. We'll probably end up with some default ones. Right now, it's just empty. But what I'm going to do is I'm going to create a privileged policy or an unprivileged policy and a privileged policy. So here it's unprivileged. If I expand this, you can see all the different types of options that are available. So basically, these are different, like if you're allowed to do privilege escalations, that has to do with capabilities. Whether or not you have access to like host namespaces like IPC, PID, and network, whether or not you can do privileged containers in general, that just basically gives you full access to the host. There's an option here for if you want read-only root file system. Like you can just say that every pod that's deployed has to have a read-only root. That's pretty strict. I don't see most people doing that because most of their applications can't handle it. If you can do that, you end up with a really clean environment because basically you have to then make sure that anything that writes to disk goes to either a tempfs or some type of other volume. You can control all the capabilities, what people are allowed to do. You can control what volume drivers people are allowed to use. You can say all of them or just specific ones, because there's some volume drivers that make sense that a lot of people are going to want, like empty dir or secret. Was config map in there? so downward API, some of these are like, they're not actually real volumes. They just give you access to information like config map, downward API. But you probably don't want to give access to host path, which is like, that gives you access to binding things on the host. So like you could just bind mount in like the etc password file or shadow file. So you probably don't want to give access to that one. So you could choose which ones they're allowed to do. And then there's even more control over, if you allow someone to do the host path, you can also say, okay, they're allowed to bind mount certain paths on the host, but they're only allowed like from, this directory, which I know, like it's like a scratch space and they can't screw up the rest of the host. So like you can give them access to specific paths on the host. And so you can create as many policies as you want, pod security policies. Then I'll show you how they're assigned. So you could create different ones for different paths or whatnot. And then there's other things of like FS group policy. This is basically like what user IDs they're allowed to run at or set, or well, this one's for the file system. So like, because you can tell Kubernetes basically to like chown the directory or set it up a certain user. This is what they're allowed to use as. So you can say like, nobody's allowed to run as root, or you can say like a specific range of UIDs. SE Linux, and this is, I'm not going to go into, so this is SE Linux. This is like very specific level. Like if you run SE Linux, hopefully you understand what these things are. But you can specific tags and for SE Linux policies. Okay.
Darren,
so yeah.
Just as we kind of come up on the half-hour mark, I think there were a couple questions about kind of the user experience, specifically around logging and catalogs and support for Helm, and kind of the bit we talked about at the end. I mean, how do you actually drive people to consume this? What's the purpose of pipelines? Do you think maybe you can touch on that? I think we've kind of before we wrap up the demo part.
Sure. I mean, so so basically, this gets a lot into kind of consuming. So right now we have like, you can set up global level catalogs. So we have kind of some pre-configured ones. Library is like a set of catalog entries that are, kind of tested and maintained by Rancher. Like we know these ones are going to work really well. These ones are the Helm repository. So they have stable and incubator. So this one, there's a lot of community stuff that's out there. Or you can go and add more catalogs. So again, there's access control around this. You can define who can add catalogs and whatnot. So this is going to give access to basically being able to deploy applications. And so we will have project level catalogs coming very soon. Right now, it's only configured at a global level, but we'll allow you to do it at a project level too. But basically, once you have these catalogs enabled, you can just go into one of your projects here and deploy any application. So let me pull from ours, because I know these are pretty well tested. So basically, you can if you want to hear we're deploying MySQL, you just go through and answer whatever the questions are, users, password, blah, blah, blah. Okay. But so there's stuff that's available out of the box for Helm. Honestly, I don't think that's the biggest value of kind of catalog and Helm. It's actually building Helm and catalog entries into your own workflow. And so what we see people doing a lot is basically they package their applications as charts, and then they can use that of basically deploying those applications in in the different environments. So like constructing a Kubernetes deployment can be a little cumbersome and like coming up with all the YAML and figuring it all out. So basically what a chart allows you to do is just take all those YAML, you can add some questions and tokenize things and turn it into this very simple to deploy unit. So it's like, here I've deployed MySQL. Here, like it's created, just this workload, this service, these secrets, like creating these various things. And now this is all managed as an application. So, you know, what we would see is like in development, you're creating deployments and pods and services, and you're doing all this stuff. But as soon as you're like, okay, now I want to, like, I now have my application, I really want to like move it through the pipeline of like from dev to test to production. It works a lot better if you end up packaging things as a Helm chart, because now once I have this, I can then just go and upgrade and downgrade. Here, I think I only have one version. But if there's a different version, I could just select the new version, click that, and it'll just upgrade the application. And you can manage that all as one big unit. And when you're deploying these applications, we went through quite a bit of effort to get the RBAC working properly. When you deploy an app, it uses the privilege of the end user, like uses the privileges of the end user. So if that application is trying to do something that the end user does not have privileges to do themselves, it will fail. So like, you know, if it tries to create some, you know, cluster level object or whatever, and that user's not allowed to do that, then it'll fail. So this is all then locked down to kind of the specific privileges of the kind of the deployer. So let me see. So we have a pipeline functionality. I'm trying to turn it on real quick.
One of the questions about Helm that came up just a second ago, Darren, was Jock asked if you could use Helm CLI remotely with Kubernetes clusters created by Rancher. And I think someone else asked about you could access Tiller directly. Do you want to just talk about those things?
Right. Okay. So yeah, that's a good question. So we have our. So the answer is yes and no. So there's a lot of problems with Helm in terms of access control and managing it and whatnot. So what we do today is we can take any Helm chart and we can deploy it, and we'll do it securely. We show it through like the GUI. We have a command line utility to install, upgrade. Like you can do everything from the CLI to manage these charts and deployment upgrade. And that's all basically Rancher specific. So we take the standard Helm charts, any Helm chart, but the way it's actually deployed, upgraded, rolled back is actually specific to Rancher right now. And so we have CLI, API, UI, whatever to do that. So you can automate it and everything. So if you want like the standard Helm command line, you're basically, because this is just Kubernetes, you can run that. But it's not going to be kind of integrated into our UI and show it everything. The reason for that is it's difficult to manage Helm from a secure perspective. What you basically need to do is you need to run a tiller under your specific account, and then like you run tiller with your own privileges. So you set up a service account, but the problem with that is once you have tiller running, you can give it a certain level of privilege, but it's still running under a service account with a certain level of privilege. Now, any user can then access tiller. So you can secure tiller with TLS certificates and lock down the tiller API, but then it's basically whoever can get those certificates can deploy it. So it's just effectively, like right now, the way Helm is, it's really hard to manage an enterprise situation. So we started down the route of like doing all these crazy approaches with tiller and whatnot, and then we just ended up having to just basically say, okay, we're going to take standard Helm charts, but kind of wrap it in our own approach, because it's just not quite there yet. So Helm 3, they're really looking at changing a lot of this, dropping tiller, moving everything more client side. It's going to make authorization and stuff much simpler and much easier. But right now, it's just very difficult to do. So it's kind of like, I really think like, you know, users running Helm and tiller themselves it's like running with scissors. It's really easy to do something bad, because you're basically deploying something that's listing on a port that has privileges, that is deploying applications, and so it's very hard to kind of control that properly. So, but you can't do it if you want to. I'm just saying it's hard to do it securely. Okay. So pipeline. So we're talking about catalog, and I just want to show the pipeline. So basically, pipeline is just a very simple CI/CD approach. I wasn't planning on demoing this, so I'm probably not going to do a very good job of it. But basically, the idea is you can hook up. Right now, it only works with GitHub, but based off of some GitHub repo and triggers, like if there's a pull, PR, tag, whatever, we'll then go and let me see if I can find some repo. Okay. So you can see these are the different build triggers. So build it whenever there's a git commit, there's a PR, there's a tag, or there's the last option is actually just do it based off of a cron job. So I'm going to just say like based off of a PR. So now basically whenever there's a PR, it's going to go through this pipeline. You can define various stages. Like we just give you kind of a default one set up, but you can actually fully customize this. You can remove this stage, you can add another stage. But we just kind of give you that. Basically, what you're going to want to do is clone, probably build something, and then publish an image. And then, so each different step here you can do basically you can either run a script or you can publish an image, and then we're going to have deployment too, so you can just basically deploy to an environment. So this gives you kind of like the full end-to-end, like you put something into Git, it will then end up doing a build, and then pushing out the image and then deploying it. So you can get like the full and then all of this is controlled like in terms of like the secrets, like within your workspace you can manage sorry, not secrets, basically the what access, like what registries. So this then pulls in the user accounts, like when you're pushing images or deploying. This is all being done under under the privileges of basically the workspace. So that's a quick thing. Like we could probably do like a full meetup actually just on pipeline, but so that's just kind of like just a quick overview of what you can do kind of with the pipeline feature. It's just basically automating the CI/CD flow. Was there another thing, Shannon?
Darren, I think it's fair to say, what we tried to show in this was creation of lots of different types of clusters. On-premise clusters can be created, using multiple different methods. You can easily kind of create cloud clusters, but across them all, the concept of delegated administration, the concept of sort of access control policies, centralized security rules that can be pushed out is there, but it's also quite customizable and configurable so that you can modify it based on the requirements that you actually have for the real world. Where I think there's a lot of work to be done still is on the last point I mentioned, like can we continue to make it easier and make it more intuitive for more and more teams to pick this stuff up. Secrets is a good example where there's really easy, simple to integrated secrets in the system, but other teams are going to have Vault. They're going to want to use other existing stuff. So making sure that those things are very easy to connect as well. Monitoring is one that we really haven't addressed yet at all, right? You see there's basic alerting in the platform right now. Darren was trying to show, I think maybe he had a chance to show alerts and notifiers, but next step is, okay, let's see real monitoring. Let me look at, can we integrate Prometheus from Grafana and see everything that's happening in real time on my cluster? So I know we have tons of additional questions. What I'd like to do now is I'd like to kind of wrap up the demo session, kind of go through a couple slides, and then what we'll do is we'll come back and we'll just start going through the remaining questions, one at a time, and Darren can demo on that for the next 30 or 40 minutes as we go. So, with that, Darren, I want to thank you for a very good demo, especially after getting off to a nice rocky start, as usual. Mm-hmm. we managed to pull it together, and I'm gonna sort of take back the controls now. Hopefully, everyone can see my screen. So what I wanted to just kind of leave you with was, if you haven't set up Rancher yet, or you haven't tried it. As Darren said, it's very easy to set up. You just need a single host to set up Rancher, and for the vast majority of use cases, that's going to be plenty. If you do need to get into more HA configurations, there's options out there, and there's documentation for it. But otherwise, just get a server up and running, and you can see all this. As always, it's all open source. It's all available to anyone. We do need lots of help from people in the community. So if you haven't already, please take a look at the docs. You can see our quick start docs here. I think we just changed the look of these. I should have updated the image.
Shannon, I wanted to just point out, going back to that last slide.
Yeah.
The slide wasn't updated. The tag, it says preview.
Yeah.
I think if you use preview, it will actually work today, because we know some users were still using that for the preview. But you're going to want to use latest or stable. Latest is always the last release. Stable is a release that's a little bit more baked in.
Good point. Thanks, Darren. So yeah, the other thing, I know there were some questions about the docs. We're still working hard on docs for 2.0. They are very much a work in progress. We could really use help on them. All of the Rancher docs are open source. They're available if you just go to github.com/rancher/docs. Pull requests are rewarded with lots of love from the Rancher community. So if you've got some time, or you see something that's just wrong, or you think there's an opportunity to improve them, it's a labor to really bring the docs up. The 1.6 docs, really got very good. 1.0 docs, but it took a year to really get them to that stage. So we're working very hard to really build great docs. You've got 2 doc writers working full time on it, so hopefully you'll see a lot of improvements in those as we go. As always, like I said, you please get involved in these projects. Whether it's the Rancher project, the RKE project, the Rancher OS project. Everything is Apache licensed open source projects that we really we love stars, we love help, we love people who want to help us by contributing issues and forking what we're working on. So please don't hesitate to get involved and to to kind of come back with questions or thoughts on how we can make these things better. There's a lot of areas, if you saw some of the questions that were coming in, where there's room for drivers and plugins into Rancher. We support just GitHub today for the pipelines Darren kind of briefly showed, but a lot of people are using GitLab or using Bitbucket. We'll be taking these things on as we go, but there's definitely room for more, and there's room for more integrations. The same goes for sort of cloud providers. We support a handful of hosted Kubernetes services. We're working on DigitalOcean now, but there are dozens more. There are lots of great places. So we're working on documenting how to add these drivers. But if you just want to add one and you want to work with us on it, just reach out. You can reach Darren or I on GitHub or Slack, or on Twitter, or just emailing us, Shannon at Rancher, Darren at Rancher. We're always available if you want to kind of reach out to us and have suggestions or ideas on how you can participate. So please, don't hesitate to kind of come back with ideas on how you can get involved. With that, I will thank everyone for coming, and I want to kind of switch back to Q&A time. So Darren, why don't I transfer control back over to you. I don't know what's going on here. There we go. And I will I'll start kind of with a couple questions that came in at the very beginning, some things that either we didn't have a chance to answer or didn't get to. So one of the questions came in was could you tell us if the communication to the etcd cluster SSL or TLS is encrypted in a Kubernetes cluster deployed with RKE? So do you want to maybe take a hack at that one, Darren?
Yeah. So the short answer is yes. So basically, we manage all those certificates and deploy them, and yeah. So everything is using certificate authentication and encryption and whatnot. So that is there in place. That's honestly, that's one of the more difficult things of manually setting up an etcd cluster yourself, is managing the certificates. And so RKE just makes that pretty super simple. Oddly enough, we have seen actually people use RKE just to manage etcd. Like just because it's a very simple way to deploy, an etcd cluster and not use Kubernetes.
Another question about sort of the Helm stuff. Nikos asked, I'm sorry, is Helm Tiller accessible directly from the Helm CLI? I don't know if you covered that already, but I figured I'd
Yeah, so I covered that quite a bit. So you can run Helm and Tiller yourself if you want to. The charts that we're deploying, we manage it ourselves. We have a separate CLI API UI for it. It's fully automatable and everything. But as I talked quite a bit about, there's a lot of security issues. It's very difficult to deploy Helm in a secure way right now.
Got it. Another question was, could you please quickly touch on the process of rotating nodes, or more broadly, what happens when a node dies within a cluster?
Yeah, so when a node dies, basically what's going to happen is when you see here, I only have one node. Let's put some more, but when a node dies, what you'll see from a Kubernetes, from like our UI and whatnot, is it will just show that the node is not ready. It'll be unavailable. Once Kubernetes sees it's in that state of not being available, it will start moving workloads around. So if there's pods that should be there, but it can't contact the node, then it will start deploying them other places. So it will still show in our UI as like, here's a bad node, but your workloads are fine. Like Kubernetes will basically reschedule them and put them where they're supposed to be. After a pretty long amount of time of a node not being available, Kubernetes will delete it. I'm not sure what that period is, but typically, most people typically end up going in and deleting them manually if you want to get rid of that node. But so there's kind of a difference, because just because you see the node is there and it's bad, it doesn't mean that your workloads are bad. Like Kubernetes will do the right thing there. So that's like when if a node goes bad. If you want to do like maintenance, there's two different operations for that. Like right now, they're just available. Like you can do it through kubectl. We're going to build them into the UI, and so you can do it from here too. But it is available in kubectl, so that's pretty good. It's basically there's two operations of cordon and drain. Cordon basically just says don't put any new workloads on there. Anything that's running there is fine, but don't put anything new on this host. So that would like basically stop new things are being deployed to be put on there. So once a host is cordoned, you can start moving the workload off. Now there's a different operation called drain from the CLI that basically what it will do is does a cordon, and then it starts killing the workloads, like moving them to different hosts, and it does it according to the pod disruption budget. That's something you can set on your applications and basically say that like I'm only like this deployment, I can withstand 30% of the pods being down. So it will ensure that as it's killing things, it doesn't violate that rule. If it can't do anything without violating the rule, then it will just hang. It will just basically say like I can't proceed forward. So that's like a more graceful way of moving things off. And then once the workload is moved off, then at that point you can then just delete the node. So that's if you are urgent, or if you're doing maintenance or whatever, you can then do the maintenance on the node, reboot, do whatever you need to, and then uncordon it, and then it will be started being used again. So that's how you do the maintenance on the nodes.
Cool. Here's another question, Darren. Is it possible to point a wildcard domain like *rancher.domain.de to a reverse proxy service /pod, so services can be exposed directly to container name.rancher.domain.de? So can you set up sort of the wildcard domain and show how that works? That's a question from Weijin. Thanks.
Well, so Kubernetes does not, like in terms of the Kubernetes constructs that exist, you're not going to be able to directly accomplish that, but you can do something like that through like Traffic. Traffic would be a good option for you because Traffic has integration to Kubernetes and it will do basically the service discovery. So I believe they have like kind of a routing policy like that where it will do like, you can even like Traffic will do Let's Encrypt, which is cool too. So like it just gives you certs by default. And then if you put in foo, it will look for a service called foo and then route it there. So Kubernetes directly doesn't have like something for that, but there's a lot of other projects that would do that. I would look at traffic. That's the one that I know. I'm pretty sure like will satisfy that use case.
That's a perfect question to lead into a question from, well, I don't see the first name, it's just A Miranza. He said, is there a plan to support traffic for ingress controller?
Well, so, I mean, basically what we do right now is if it's a cloud managed distribution or imported, then we don't really know what ingress you have running. It's up to you, bring your own ingress. If it's a rancher, if it's a rancher distribution, let's see, this is almost up. It says this message when the nodes are still deploying the networking. But if it's a rancher distribution, let me see, we go and add a new cluster. Let's see if we have the option, cluster options. Oh, it's not in the UI, but there's an option that basically, like once you already have a cluster, I'll show you. Do an API. There's right now we set the ingress provider to Nginx. That basically you can just disable that. You can turn that off, or if you wanted to, you can actually just go into the the ingress one, and you can just basically delete that namespace, and that would delete the Nginx controller. But basically, you can deploy your own. So what we really want to be able to do is make it such that, so we have these catalog entries. Sorry, we have these catalog apps here. We really want to be able to just have all the various ingress controllers that are available out there as just things that I can just deploy. So like right now, I think traffic. Oh, is it not? There's not already a traffic one. That's a bummer. Maybe it's in incubator. Let me see if there's other ingress. Oh no, here it is. Oh, maybe I spelled it wrong or something. Yeah, so like right now you could actually just deploy this, and that should deploy the traffic ingress controller, and then you can configure it however you want. So it's like it will work today. It's just like we deploy the Nginx one by default, so like that one's gonna behave as the default one. So if you deploy a second ingress controller, you have to say specifically what ingress you want to use. Can't remember the actual annotation that you put, but you just put like an annotation to say, okay, I want to use traffic, or you just delete the Nginx one that we provide and do the traffic one. So it basically works, but we would like to actually just build like more first-class support into the UI for ingress controllers.
Darren, there was another question about the Nginx ingress controller, and that was from Chris. He said, is the rancher Nginx ingress the ingress controller from the Kubernetes repo or the Nginx repo? Do you know the answer to that?
That is a great question, because in fact we had to fork it because we ran into bugs with it. We're trying to work with upstream on getting them fixed, but we have a fork of it right now. So it is the Kubernetes one, where we're pulling from. Is there a specific advantage of the one that comes from the one that comes from Nginx themselves? I don't know if there's a specific advantage of that one. Basically, we go with the ingress Nginx one because this is like basically the most used one. It has the most amount of options. There's like 1 million options for it. Anyways, yeah, so what we're deploying is the one that's based off the Kubernetes repo. It's actually a forked copy right now just because we had to address some issues.
Awesome. So a couple questions. One question was about if there was any chance of creating a rancher operator for Kubernetes, and that was a question from Vera. Any thoughts on that, Darren?
There's not really a big need for it. Like, so the thing is, I mean, typically you create an operator to deploy applications that are more complex and whatnot. Rancher itself is actually pretty simple to deploy. So Rancher itself is actually like, you can kind of look at it as one, oops, let's see, what's our block, right? You can look at it as like Rancher is actually a series of operators to do other things, like we're doing like deploying pipelines or monitoring or some of the other things. So Rancher itself works as an operator, but Rancher to actually deploy it, we don't need so much an operator for Rancher. There's just recently, this is an interesting blog article that was put up here by one of our engineers, was basically running on your desktop. But the thing that's interesting about this is he has a Helm chart for Rancher in here. Let's see, where does he have it? So this is actually a Rancher Helm chart, which we're going to turn this into an official thing. But but basically Rancher is pretty much just like a standard application. There's not a lot to it because the architecture of Rancher is actually, it's a Kubernetes application. It runs on top of Kubernetes. It uses fully CRDs and all this stuff. So our persistence layer for Rancher is actually Kubernetes itself, which then makes it so like if you already have a Kubernetes cluster, if you want to deploy Rancher inside of it, it's super simple. Because it just basically takes advantage of all the Kubernetes services that are available in the cluster. But anyways, there will be a Helm chart that's coming pretty soon. There's already this one that you can install, but we're gonna make this official. We'll get it up into the Helm public repos.
There's a couple questions that came in. Someone had asked why in the dashboard we show that you can only have up to 110 pods on a host, and I had responded that it was a limit within Kubernetes, and there was sort of a question that came back, a couple questions that came back about this. One was the asking, is that actually for pods or is that for containers? If I have multiple containers on a pod, does that 110 become an issue? And then also how many pods are being consumed by just sort of the system on an existing host. So do I really not have 110? I have some subset. So anything you can add there, and then someone else mentioned that you can actually, there's a kubelet-max pods configuration that you can change if you want to change that to be more than 110. So maybe you can kind of discuss it.
Yeah. So you kind of touched on it quite a bit. So basically, yes, it is the default. I'm trying to find it in here. There's a default of max pods. So this is just a parameter on the kubelet itself. So the kubelet by default, they set it to max is 110. So that is pods, not containers. So it's just the number of pods. So we just run with that default setting. You can bump it up. Typically what's going to happen is most Kubernetes deployments, like it depends on what networking model you're using, but a lot of them are doing like a /24 per host, or something maybe a little less than that. But like typically what I'm getting to is if you bump that number up too high, you're going to start running out of IPs that are available on the host for networking. So then you have to start tweaking the networking so you get more IPs available per node. So it starts getting tricky. So if you do want to go a lot higher than that, because you're going to start hitting issues around like 200 typically. But if you're looking like 1,000 containers, whatever, which I'm not terribly sure how well Kubernetes will handle that, like that many containers. But if you want to go up to like something like that high, then you really need to start looking at the networking because you're going to hit a limitation on that. But if you want to change this, you can. So like, when we demo, we show a lot of stuff for the UI. There's different approaches to like API and CLI of how to do this, or you can deploy RKE clusters yourself and then import them into Rancher. So for every possible tweak or knob that there is in Kubernetes, there's a way to get to it. It's just we don't typically like show every, because there's just a million options. We don't show them all like in the UI. So it is possible to deploy like RKE through Rancher and set the max pods to a different value. There's just the extra args on the kubelet service in the RKE configuration. So you can change that. So one of the questions was, well, how many like pods, like is that 110 already eaten up by you know, some of the system stuff? And the answer is, well, yeah, some of it is. So you can, let's see, where do we have? So like this one, no, so you can see like this is like this cluster, well, this is GKE. GKE, like I haven't deployed, I don't think I've deployed a single thing on this GKE one. You can see 19 pods are already being deployed out of the 330 because there's 3 hosts. Changing this option for cloud managed ones is going to be iffy. So I don't know exactly how to change it for like GKE or AKS or whatever. I just know that we can do it for Rancher, like the Rancher managed ones. But yeah, so there's typically, I mean, you're typically running like 5 or 6 pods, I think, per host. So that, but you know, it's not like 20. It's not, so a little bit of your capacity is taken there. But anyways, but you can tweak and tune all this stuff. 110 just seemed like, I don't know. They seem like that was a good default.
Here's a question that Eric just asked. He said, is there an easy way to upgrade a Kubernetes cluster from 1.9 to 1.10? What about HA clusters? How is it different, you know, between in a cloud hosted cluster? Maybe you can talk about cluster ops and management for just a second.
Yeah, so as long as it's deployed through, if it goes through, like if you're deploying, because, you know, again, there's a million different ways to do this. If you're importing a cluster, we have no visibility to what it is. We don't know what it is. It's just, I mean, we can tell you it's this version of Kubernetes, but I can't upgrade it because I don't know how it was deployed to begin with. So that's how for an imported one. But if it's a cloud hosted one or a Kubernetes cluster managed by us, then we can do the upgrade. So here I've deployed, I don't know what version of cluster, I deployed 110. Oh shoot, that's the latest one. But if I was to do, I'll show you. So if I add a cluster, let me just do, I guess I can do DO. So here, basically, oh, is 110 the only one that we have available right now? It's odd.
Maybe basically.
Well, the short of it, and we might only have, I'm surprised because typically we have.
Some of them you can do 1.8, 1.9. It may have something to do with what you're running in DigitalOcean.
Yeah. So, but basically the short of it, it's all you have to do to change the version is just go edit the cluster, go to cluster options, change Kubernetes version. So that's for like this is an RKE based one. So this is if the kind of the same thing applies to a cloud based one. I have to put in the credentials again. Here. Oh, here it is. Yeah. Here you can just choose a different version if there's one available. So yeah, so you can do the upgrades that way. I'm not exactly sure right now like why I'm not getting more available because typically I'm pretty sure we have 1.8, 1.9, and 1.10 in Rancher.
It might have something to do with the Docker machine to provisioned ones. I know you can do it for other ones. I don't know what's going on with that. And another question that came in was kind of following that, and it was that, you know, on 1.6 we can upgrade the deployment of Kubernetes, adding and removing or updating options of kube components like kube API parameters, kubectl parameters, and so on. How do you do that in 2.0?
I mean, the simplest thing, if you want to get super advanced, is actually just run RKE and import it, because RKE will give you access to absolutely everything, and then you can just import it. Right now, if you go through, let me try this real quick. Let me download this If you go through the CLI, I believe we give you access. I'm pretty sure in the CLI we give you access to all the options too, because you can just pass like a config file. I have to double check on that one. Or kind of the last approach is basically just going through the API, because it is all in the API of basically if you edit one of these clusters, it's this big long, I know this is not very user friendly, but there's this big long JSON blob right here that has all of the options in it. And what this JSON blob is here, this Rancher Kubernetes engine config, is the same thing that is in the cluster config for RKE. So the intention was that what we wanted to do is for people who wanted like more advanced setups is we wanted to just basically enable a lot of that through the CLI and API, not necessarily do a lot of it through the UI, because there's a million options. But if you look at here, cluster YAML, this gives you an idea of if you want to change, like let's say like the kubelet, we have some of the standard parameters here, like cluster domain, DNS, the infra image, but then there's also, you can just put extra args. You can put that on any service and you can just put whatever arguments you want. So you can configure anything. So you should be able to accomplish it.
Awesome. There was a question a second ago asking if there were any plans for managing network policies via the Rancher UI. Anything you can talk to there, Darren?
Yeah. I mean, so basically, yes, we want to do that. Kind of the queue of work right now is right now we're heavily focused on resource management. So we'll be doing, you'll see that in kind of like the next release of like setting up quotas and assigning them to projects and namespace and whatnot. And then I think after that, we'll probably get to the network policy stuff. So I don't think it's currently like scope for 2.1, but we do plan on supporting it. It's fairly limited what you can do. Network policy, yeah, I mean, there's some little, you have to be really careful about it. So we're gonna have to put some thought into it because it's really easy to basically create something that you think is secure, but it's not. So we really have to put some thought into trying to do that in like the best way possible to really make it secure.
Here's another question. This question was from George. He asked it a while ago. So George, thanks for your patience. He said, we have two VMware instances, one for production and one for staging, and they're separate. Is it best practices to have different hardware for your staging environment? Sorry, kind of broad question, but I've been building Rancher and staging and realized I have to have two instances of Rancher, one for staging, one for production. If I separate staging from production with a namespace, would it be best to run that all on the same hardware and cluster? And there were a couple other questions like this, Darren, over the meetup, which was just like kind of what's the real level of recommendations on isolation? Should we have different clusters for staging and productions? Are namespaces enough isolation? How do I understand the impact, and why does it make sense to isolate in different ways?
Right. So, it's kind of up to you. You can choose all these different approaches. What I kind of really recommend for people is you separate dev and test and staging and production into different clusters. And sometimes people will even go as far as like two different Rancher servers. I don't think that's as much needed, but sometimes they'll do that. But basically, it's a good idea because the kind of the noisy, even if you lock things down of like how much quota they can take, how much the pod security policies, all these different things, there's still side effects, like some noisy neighbor side effects of running applications. So definitely you don't want like dev and test on the same cluster as production. So I would recommend you separate those two things. And so when you look at like moving an application from one namespace to another, as opposed to moving an application from one cluster to another, is not really much different. It's like export YAML, import YAML, or take this Helm chart and deploy it. So operationally, not a lot changes if you're talking about moving between different clusters or between different namespaces or projects. It's all basically the same thing. So you really just have to look at like failure boundaries, impact, and whatnot. And so I really recommend staging in production. And it depends on what you do in staging. If your staging is really just like, I'm staging my app, I test it out, it's good, then I push it to production, then that can be on the same cluster. If like staging, you do like some load testing and whatnot, you might want to get a little careful about putting that in the same as the production. But that's kind of how we would recommend, typically recommend. And then in terms of the number of clusters, like, should I have a lot of big ones? Should I have a little small ones? You have to kind of balance that. Like the bigger the cluster is, kind of the more headache you're going to have of like, making sure etcd is scaled properly. Like what are the failure boundaries? Like if this goes down, how many applications and nodes are. So I don't really recommend running huge clusters unless you have an application which is huge. Like so some of the like TensorFlow or things like where it's like the nature of the application is they just run over thousands of nodes or whatever. Well, that makes sense because like it's one application, they just run it over big. But like if you're talking about like a lot of different teams using it, typically don't want to go too large on clusters. But on the flip side, you don't want to go too small, where like you say the cluster is just like 5 nodes, because at that point the control plane, the amount of resources for etcd and Kubernetes ends up being like a larger percentage, like you're wasting money. Because you're having to pay for the control plane too. So you have to find kind of like a nice balance, but there's not like, in my mind, a huge advantage of like people have this dream up front with Kubernetes of like, I'm just gonna have one cluster, put everything on it. Like that's just kind of a headache. It doesn't really seem to work out the best.
Yeah, there was actually another question about that specifically, which was asked. It said this was a Paul asked this question about 20 minutes ago. He said, "What the recommendation for etcd is 3 nodes. What's the recommendation for control plane nodes? Also, is it okay to have etcd and control planes on the same machine as the worker nodes? So, what's the implications of running it all on just 3 nodes or kind of a 3-node cluster with everything in the same place versus separating out the layers? I mean, what would you recommend for production? Really don't want this to go down type of thing versus normal deployment."
Yeah, so like a production, you don't want this to go down type situation is from the control plane, basically 3 etcd servers, and then two control plane servers. So it's 5 servers total. You can put the control plane on the etcd, just make sure they have sufficient resources. Etcd is, you just don't want the, you just don't want to be like a very taxed server, because if etcd starts behaving poorly, then that's where you're going to have like the biggest problem in your cluster. So, for the safest thing, 3 dedicated etcd hosts, and then put the control plane on 2.
What would you recommend sizing wise? Is there any kind of sizing guide on those etcd? How much RAM, CPU to give them?
I don't know. I can't really say off the top of my head.
Yeah.
There are some sizing guides online. There's some good stuff. CoreOS, they create etcd, has some good guidelines. So the information is available. I don't know off the top of my head. I would just tell you the biggest thing is the speed of the disk and the speed of the network for etcd. So you want to put it on, don't put it on spinning disks. Put it on SSDs. Put it in some type of low latency network, because that's what's going to kill you. Is what we see a lot is networking, like if you have kind of a spotty network, because with Raft, there's this heartbeat, and you can configure the heartbeat in Rancher, but that heartbeat, if the interval is too big, then Kubernetes is going to run really slow. If it's too small, if it's small, Kubernetes is going to run faster, but it's more sensitive to blips in the networking. So it's like all about kind of tuning that parameter. The defaults we have right now work pretty well for like cloud setups, but it's not going to give you, it's not the fast, we kind of optimize for a situation, we tune it for what's going to work pretty much everywhere. But if you're getting into really high, like a really large cluster generating a lot of events, then you're going to have to basically put etcd like on higher performance machines and then tune that value to be lower. So it takes some tuning. I mean, etcd is the biggest administrative aspect of Kubernetes.
When and from the high latency, the low latency networking perspective, that's the key is between the etcd nodes, not necessarily between the etcd nodes and the control plane or the etcd nodes and the workers. Is that right, or does it all need to be on low?
Yeah. No. So like the real sensitivity is between the etcd nodes.
Yeah. Okay.
They need to be able to basically, when you send a write to the master, it's then going to send the writes to the slaves. And that whole, like, it has to do this whole round trip, it goes through the heartbeat. And so it's like, that all has to be like confirmed. So if you have a slower network, the writes are going to be a lot slower. But then also if you have really slow, then it will miss heartbeats, and then it starts, reconfiguring the cluster, and that's when things go really bad. So it's between those. And then Kubernetes, like how far away you put the control plane, like the API server or the workers, is just basically going to impact how fast things run. Like it can deal with a fairly, like not the best network. It deals with it all right, but it's just things will definitely like slow down.
Cool. So I think we've covered most of the questions. There was a handful more, but I think we need to wrap up. It's already been 2 hours again. I know Darren and I set out this morning and said, I think we can do this one in an hour, and we failed as always. But Darren, I really appreciate you answering so many questions. For everyone who's still on, thank you for spending your afternoon or morning or lunch or evening or whatever time it is in Asia. I saw some people joining from Asia. So thanks everyone. Next month we're probably going to be diving into continuous delivery and CI in a lot more depth. That'll probably be our main topic next month. So if you have any other ideas, please don't hesitate to Slack them to us or tweet them to us for topics. It does seem like storage is one that there's always lots of questions on. So I did see a bunch of people asking questions about PV and vSphere storage services and what's good, what's bad, what would work. So maybe we'll pump that up quicker as well. But otherwise, thanks everyone. We hope to see a big crowd again next month. Have a great afternoon, day, evening. Bye-bye.